This is the angles in the same segment theorem. In this video, we're going to find out what it is and where it comes from. If you find this video useful, please consider leaving a like, a comment, and subscribing to our channel for more content like this. Circle theorems are sets of rules that describe the relationships between angles, lines, and arcs within a circle. They provide a framework for understanding geometric properties within circles and are useful for solving problems involving circles. The circle theorem we're going to investigate here is called the angles in the same segment theorem. The theorem is illustrated in this diagram, where the points A, B, and C form an angle on the circumference of the circle, and points A, B, and D also form an angle on the circumference. The theorem states that angles subtended at the circumference in the same segment of a circle are equal. In other words, lines drawn from either end of the arc AB to a point on the major arc in the same segment create angles that are equal in size. Those angles are ACB and ADB in this diagram. In this video, we'll show you why this is the case. But before we go any further, let's define four terms. A chord is a line segment that connects 2 points on the circumference of a circle. An arc is a portion of the circumference of a circle, where the longer arc is the major arc. A segment divides the circle into 2 parts. The larger is the major segment and the smaller is the minor segment. And a subtended angle is an angle formed by 2 lines that intersect at a point on the circumference of the circle. Now let's look at one important angle fact you may already know that we need in order to be able to prove the angles in the same segment theorem. This diagram shows that the angle made at the center of a circle is twice the size of the angle made at the circumference when they originate from the same 2 points, A and C. In the context of our diagram, that means angle AOC is twice as large as angle ABC. A radius drawn from point A to the center O and a second radius drawn from the center to point B creates an obtuse angle at the center of our circle AOB. Let's label this angle with the letter X. let's also label the angle subtended at C, ACB, with the letter C. The angle at the centre, X, is twice the size of the angle C, which we can write as X equal to 2C. A radius drawn from point A to the centre O and a second radius drawn from the centre to point B creates an obtuse angle at the centre of our circle, AOB. Let's label this angle with the letter X. Let's also label the angle subtended at D, ADB, with the letter D. The angle at the centre, X, is twice the size of the angle D, which we can write as X equal to 2D. Given that we have found X equal to 2C and X equal to 2D, that means 2C is equal to 2D, which can be simplified as C equal to D. So the angles subtended at points C and D are equal. And that's the angles in the same segment theorem. If you found this video useful, please consider leaving a like, a comment, and subscribing to our channel. Thank you.